Hey everyone, I'm going to go through the semester 2 exam review that's on Kognity, and little disclaimer, I didn't get through a couple of questions because I underestimated how long it would take to understand them, so I'm choosing not to go through them, but I am going to do a separate video by myself to go through those questions, and I'm going to go through everything I do know right now. So the ones that I won't be able to get through in this video is 5 through 11. But there are Kognity explanations. If you open up your Kognity, there should be the drop-down explanations. Hopefully those help if I don't get the video posted before you go to sleep. But yeah, I'm gonna get started. Okay, question 1. Consider the data in this table for a mass on a spring. Use a calculator to find the line of best fit. So this one is super simple. We know that we're dealing with 2 different variables, and we know that and since we see the words of line of best fit, we know that's referring to Pearson's. So we would just plug in the given values into L1 and L2, go to stat, press calc, and then line regression. Make sure there's nothing next to frequency list when you're putting in your L1, L2. And then once you press calculate, you should get this value. This one's super simple. It's just a small review. So I'm going to go through that again. Plug in your given values into L1 and L2, and then go to stat, calc, and then go down to number 4, line regression. Make sure your columns are there. Make sure there's nothing next to frequency list, and then calculate. And then you should have the variables to put together your equation. That's pretty simple. Question 2. This table shows the average hours per day 6 fathers spent doing physical exercise and the average hours per day each father's eldest child spent doing physical exercise. Use your calculator to find the correlation coefficient for the data. Give your answer rounded to 3 significant figures. So this one's basically the same concept as before. There's 2 different variables you're looking at. So we know that we're working with Pearson's, and then you would take each of the given values from the X variables and the Y variables, put them into L1, L2, or whichever columns you have open, and then click stat, calc, go down to number 4, line regression, put in your columns, make sure there's nothing next to frequency list, calculate, and then you should get, when you round your final value, you should get 0.974. And make sure to have 3 significant figures, or else Ms. Sinha will take off points. So remember that. Pretty simple. Okay. Question 3. Hannah produces a table of the price of a cup of coffee versus distance to a popular beauty spot. What is a y-intercept for the line of best fit? Give your answer to 3 significant figures. Same concept as the last 2 questions. We're working with 2 different variables, so we know that we're working with Pearson's yet again. So take the values, plug them into L1 and L2, click stat, calc, go down to number 4, line regression, put in your columns, make sure there's nothing next to frequency list, calculate, and then you have to find the variable b on your calculator, and then that value is your answer, because in the equation y equals ax plus b is that y-intercept of the line for the line of best fit. So that would be your answer. And then once you do all the rounding, you should come up with 3.21. Pretty simple. So it's the same thing over here. Okay. Question number 4. Alistair throws a biased 6-sided dice with the numbers 1, 2, 3, 4, 5, and 6 written on the sides. The probability of getting a 6 with this dice is 0.4. The other numbers are equally probable. What is the probability of getting a 1? So I solved it kind of differently than what is shown over here. So I'm going to walk through my process. So so we have a biased six-sided cube, right? Which has the sides 1, 2, 3, 4, 5, and 6. So in the question, it tells us that the probability of getting a 6 with this dice is 0.4. So we know that the probability of getting all of the other numbers is 0.6 because 1, which is what all the probabilities have to equal to, minus 0.4, which is the probability of getting a 6, equals 0.6. And since all the other sides are equally probable to get, you take 0.6 and then divide that by the remaining number of sides, which is 1, 2, 3, 4, and 5. So finally, you would have 0.6 divided by 5 equals 0.12. And then out of all of the answer choices shown below, which this was also another answer choice, 3 over 25. 3 over 25 was the only one that was equal to 0.12. So that was the answer. There's nothing wrong with doing this way, but I think for me, the other way, I understood that much better. Okay, moving on to the next question. Oh yeah, I said I wouldn't be able to do 5 through 11. So all the explanations are in here, but I will try my best to make another video covering the questions I did not get to during this meeting. Okay. Number 12, Iona discovers that the lifespan of cats is normally distributed with a mean of 12 years and a standard deviation of 2 years. What is the best estimate for the probability of a cat living more than 16 years? Okay, so we know that we're working with normal distribution because it explicitly states in the question itself that it is normally distributed. So that's the first thing. And then we know that with normal distribution, we will be looking at the mean and standard deviation. So I would also note those 2 points down. So I would write that the mean is 12, while the standard deviation is 2. So we have to look at the probability of more than the value of 16. So with normal distribution, we have to go to second bar, which is distribution, and then go down to number 2, and then which is NormalCdf. Click enter, and then your lower bound would be 16 because you want to know the probability of a cat living more than 16 years, so the lower bound is 16. And then the upper bound is 1 on your calculator, it should show 1e99, which is basically infinity. And then the next value is your mean, which is 12. And then your next value, which is your standard deviation, is 2. And then paste. And then since we want a percentage, we want to multiply that by 100. And then we should get 2.27. Yeah, that's what I got. I got 2.27. And then based off, okay, good. And then based off all the answer choices there, that's obviously the closest, so go with that. But I don't know if the questions Ms. Sinha will give us will be open-ended or multiple choice. So always remember, write down 6 sig figs and then put your final answer in 3 sig figs. Okay. Yeah, okay, moving on to question 13. Same deal, same concept as the last one. Number 13, Fiona discovers that the lifetime of washing machines is normally distributed with a mean of 8 years and a standard deviation of 2 years. What is the probability of a machine lasting between 6 and 10 years? Okay, so same deal. You want to go to NormalCdf. And then, oh, wrong one. NormalCdf. Keep clicking PDF. Okay, you want to go to NormalCdf, and then it explicitly says that our mean is 8 and our standard deviation is 2, so keep that in mind. So we're now looking at the probability of a machine lasting between a range of years, 6 and 10. So that should make it pretty easy. Lower bound is 6, upper bound is 10, mean is 8 and standard deviation is 2. So when you paste that and then multiply the value by 100 because you're looking to get a percentage, you should get 68.26, and then that's around 68%. Based off all the answer choices given, 68 is obviously the closest one, so we would go with 68. But then again, if it's an open-ended question, 6 and then rounded 3. Yeah, okay. Moving on, question 14. Okay, so this one is a bit different than the last. This one has to do with using inverse norm. So let me read the question. The marks in a math test are normally distributed with a mean of 54 and a standard deviation of 7. The top 2% of students achieve more than X. Find X correct to 3 significant figures. Okay, so for this one, first, let's go to NormalCdf, inverse norm, because that's what we're working with. And we know that because they're asking us top 2% of students achieve more than X. So we're trying to find that value more than X. So if you were to draw this out, it would be like a shaded region on your bell curve. So when you go to inverse norm, which is the third option on distribution, it asks for the area. So since the top 2% of the students, let me see if I could. Wait, Renai, can you see you can still see my Kognity, right?
Yeah, I can.
Okay. Okay. So let's say you were to have a bell curve. So this would be your mean. So I'm saying top 2%. So that would be all the way up here, maybe even less than that. So we can't, using normal distribution on your calculator, you cannot find the values you can't find the values to the right. So you need to find the values to the left. So in this case, you want to take 2%, convert them to a decimal, and then subtract that from 1. So it would be 1 minus 0.02. So then you would get 0.98. So that would be your area. So in your inverse norm portion of the calculator, you want to type in 0.98, and then for your mean, 54, and then for your standard deviation, you want to put 7, and then calculate that, and then you should get 68.3762, or as it says right here in the Kognity explanation, 68.4 rounded. Okay. Moving on to 15. Okay, so this follows the same concepts as the last question, but a little bit different. Okay, so the time to deliver a pizza is normally distributed with a mean of 22 minutes and a standard deviation of, wait one sec. Yes, okay. A mean of 22 minutes and a standard deviation of 7 minutes. During 1,000 deliveries, in 52 cases, the pizzas were delivered in less than X minutes. Find X. Give your answer to the nearest integer. So this one's kind of different. So instead of looking at the values to the right, we are looking at the values to the left, which makes it a little bit easier for us. So, oh, that's a horrible bell curve. Kind of janky, but that's fine. So we are looking at in less than X. So if it's in more than X minutes, then that would be somewhere, it will be something shaded like this. Let's say that this is X, right? But that's not the case. So now it's saying less than X minutes. So let's say this was X. So this is less than X. So that makes it a bit more easier for us. So first we need to figure out what the area is. Pretty simple. Take the 2 values that's given to you. So we're focusing on 52 cases. So since 1,000 is the total amount, that's the denominator, and 52 is the numerator. So you would do 52 divided by 1,000, as is shown, and then you would get 0.052. Let me just clear everything. and then that would be your area. And then your mean would be 22, and then your standard deviation would be 7. And then once, here, let me just put it into my calculator real quick. 22, and then 7. Once you put it into your calculator, you should have gotten 10.6196. That's just me adding more numbers. And then since it's the nearest integer and nearest whole number, which is rounded up, that would be 11. So that's pretty simple. So if this gets kind of confusing on the test, I would draw out the bell curve and shade the section you're focusing on. So if it says more than, you're focusing to the right. So you know that you cannot calculate based on the right. So that means you have to do 1 minus the value of this, and then that would equal your area. It's really janky, but you guys know what I'm trying to say. So if it's to the right, it's not right. I mean, that would help me remember it. So if it's to the right, it's not right. So that means you need to do an extra step. On the other hand, if the values you're focusing on is to the left, then you don't have to do the extra step, and you could just put in the decimal as is shown. So drawing it out always makes it easier. Even putting the mean, like putting the mean of 22, just drawing everything out also makes it easier to visualize what's going on. Okay. Moving on to 16. Okay, ignore my answer. It was late and I just put in a random number and turned it in. Okay, so the question, the lifespan of an elephant is normally distributed with a mean of 40 years and a standard deviation of 15 years. In a population of 1,000 elephants, how many are expected to live more than 85 years? Give your answer to the nearest integer. So this is also normal distribution. So make sure you have your distributions, make sure you click NormalCdf. And then this one, since it's again saying more than 85 years, we know that the lower bound is 85 because that's the value we're going off from. So the lower bound would be 85. And then your upper bound would be, if it doesn't state it, then it is infinity, which can be signified by 1e99, which is 1 times 10 to the power of 99. Scientific notation, I think we should be familiar with that because of physics, especially on level 6.
And chemistry.
Oh yeah, chemistry. Forgot about that.
Mr. Rogers will be very disappointed in you.
I wouldn't doubt it. Okay, so after you put in the lower and upper bound, you have the mean of 40, so you put that in, and then the standard deviation of 15, put that in, and then you would get a really low number, not super low, but still low, of 0.001349. That's super low. But in our case, you don't have to worry about messing with rounding because it's asking to the nearest integer, so you can't have 0. So obviously you would round it up to 1. Oh my god.
Yeah, you have to multiply to
Yeah. I was like, wait, that seems off.
Yeah, no, you have to multiply to 1,000 because it's
Yeah. Make sure to multiply to 1,000. Don't forget about that.
Because like the normal distribution, that's just acting as a probability, right? And it said how many are expected to live, so you would use the NHP thing.
Ugh, we've dealt so much with the expected frequency. I don't know. I keep messing it up. Okay, yeah. Whatever I said, thanks. So yeah, don't forget to multiply by the total. Oh my goodness. I mean, let's say you were as dumb as me to not have multiplied it. You would have ended up rounding it to 1 anyways, but let's not do that.
It's been a long day, guys. Don't worry.
Oh yeah. Okay. Moving on. 17. Okay, so This question was really wonky. So if you got to this question and you tried using Spearman's, you tried using Pearson's, and you tried using line regression, and it didn't work. Yeah, it didn't work for me too, or Miss Sinha. But there was another test that we used, which made us get the answer choices that were given to us. It most likely won't be on the test. You never know. So I'm gonna go over it really briefly. And I'm really sorry if you're not a visual learner. I wish my calculator was up on the screen. That'd be so much easier, but hopefully I'm explaining it clear enough. Okay, so I'll read the question. 2 judges, A and B, were asked to judge an event and their scores out of 10 are given below. Is there a significant correlation between the marks given by the 2 judges? Okay. So judge A, judge B. So the first thing you want to do, pretty simple. You want to put the values into L1 and L2. I'm going to do that too. .546, 7.58, 9.5, 10, 7, 4.5 and 10. Okay, so after you put your L1 and L2 in, or whatever columns you choose, quit and then go to stat and then go to test and go all the way down to F, which is line regression t-test, line regression t-test. I had the TI-84, so I'm not sure, like the basic calculator we have at schools. Like, I'm not sure how it appears on your calculator if you don't have it, but that's how it appears on mine. So go all the way down to F, line regression t-test. Click enter, make sure your columns are in there, make sure next to frequency, it says 1, and then make sure the one you choose, like after frequency, is the non-equal to sign. So the equal sign with a dash through it and a 0. Then I have nothing in the next row, which is reg EQ, regression EQ, and then click calculate. Crap, I lost it. One sec. And then click calculate, and you should get a p-value of 0.949669, which is the correct answer. And since it's way bigger than 0.10, 0.05, 0.01, we know that the correlation is not significant. Renai, were you able to find the test I was talking about?
Yeah, I was.
Did you get the same value for p?
I did not put it in yet. Whoops.
Okay, let me know.
All right. Can you repeat what you said? Let's see.
The steps?
No, just.
Oh, no, the value.
Yeah.
Here, this is the value. I highlighted on the thing. You see it?
Oh yeah. Okay, I see it. Yeah. Let's see.
Can't imagine having taken the AP Bio test and having a math final tomorrow. Ugh, I would be so tired.
I know. Yeah, I know. I'll be tired. All right, here. I'll let you know when I get the answer.
Okay. Yeah. Cool.
Yeah. Because I have it also pulled up, so I can do it. So.
Okay. Yeah. Okay. Cool.
I just realized that.
Okay. Nice. Yeah. If I were you, and if you're watching this video, I would have your Kognity pulled up as well. I just think that would be helpful. So yeah, I wouldn't worry about this, but it's not a bad thing to know. It was a very odd question, but yeah. But like, let's say you were on the actual IB test and you had no idea what to do. At least the least you could do, you would know that if the p-value is less than 0.05, the correlation is significant. If the p-value is greater than 0.05, you know that it's not significant. So you have a 50-50 chance of getting it right. Okay, moving on. So number 18, this is Spearman's question. It tells you right in the question, so that's nice. Calculate the Spearman's coefficient for the following data collected to find a relationship between the height of a certain plant and the thickness of its stem. Okay, so it's kind of time consuming to rank everything, but yeah, all you have to rank each column, and then you would put them into L1, L2, or whichever columns you choose. Go to Stat, Calc. Number 4, line regression. Make sure there's nothing next to frequency list. Oh, sorry. And then calculate. And then you should get a correlation coefficient of negative 0.17 when it's rounded to 3 sig figs. That's pretty simple. So yeah.
So for 18, was it 18?
The other one?
17, sorry. Yeah. So for that one, yeah, I got 0.94966.
Okay, great. So yeah, that's F, and that's the line regression t-test.
Yeah.
Not bad to know, but I wouldn't worry about it too much if I were you. Nice. Okay.
Cool.
Yep, thanks. Okay, number 18, pretty simple. That was just ranking them. And here's my advice, personal advice. You do not have to take it. If let's say there's a Spearman's rank question on the test, I would try and leave that till the very end, because ranking gets so messy sometimes, and I find myself doing it over like 5 times. So if I were you, and it's something that's kind of confusing, I would leave it till the end so you could spend time on everything else you do know.
Also, maybe try writing out on paper. Like,
yeah,
it really helps me.
I would definitely have a scratch paper out and write everything out, and with pencil, because you could erase things, obviously. But yeah, scratch paper is definitely recommended. You should definitely use it. Okay, great. So that is number 18. And then we have number 19. Yeah, see, the ranks are right here if you want to check your work. Perfect. Okay, you might be wondering why I am doing a review, even though the answers are right there, like, and the explanations. I just find it easier when a human talks me through the explanations, which is why I went to tutoring after school today for Miss Sinha. So hopefully this helps you in any way. Okay, question 19. Which of the following p-values show that there is a significant relationship between 2 variables? Okay. So I think I mentioned this like right before. The answer choices, 0.8. You could immediately eliminate that, because you know that your significance value would be 0.05 or 0.01. Even if it's 10%, it would be 0.10. So that's still wrong. Okay, and then you have 0.09876. We could, that's less than 10%, but we not going to eliminate that or make that our right answer. We're going to go through the other ones. And then you see 0.05, still less than 10%. And then we see 0.0012. So I would go with this. If you get a question like this, I would go with the smallest, because we know that if it's larger than the than 5%, which is the significance value in question, we know that it's not significant. So if you get a question like this, I would go with the smallest value, because it didn't give you the significance value. So the safest choice would be to go with the smallest value, which is what I did, and it was correct.
So if they ask for the critical value, right?
Yeah.
Would the critical value have to be bigger than the?
So with the critical, so here's how I think of it. So I know that the problem will always give me the significance value and the critical value. So when it comes to significance value, I know that the p-value has to be less than the significance value to reject the null hypothesis. The same way, I know that the problem will give me the critical value, but on the flip side, the chi-square statistic that you would get from your calculator, that has to be greater than the critical value in order to reject the null hypothesis. Hopefully that makes sense.
Could you repeat it again? I zoned out. Oh my God,
No,
sorry.
yeah, no, you're good. Okay, so I know that the problems will always give me the significance value or the critical value, correct? So we know that if the p-value is less than the significance value, you can reject the null hypothesis. That means that the relationship is significant, correct?
Yeah.
So that same way, they give us the critical value, and what we solve for in our calculator is the chi-square statistic. So for this chi-square statistic, it needs to be bigger than the critical value. And if it is bigger, then we know that the relationship is significant and that the null hypothesis can be rejected. So it's like one has to be bigger than in one situation and the other situation has to be smaller than. You just need to remember that, honestly.
Okay, gotcha.
Yeah.
Yeah, that makes sense. All right, thank you.
Okay, great. All right. Next question. Question 20. Does it say how much time I have left in the meeting? It does not. Okay. An automobile tire manufacturer, which is this question 20? Yeah, okay. An automobile tire manufacturer is comparing the tread life of its new tires to the tread life of its previous model to see if they last significantly longer. The values below are in thousands of kilometers. New tire, values are shown. Old tire, values are shown. Perform a hypothesis test to determine if the new tires lasted significantly longer than the old tires with a 0.05 or 5% level of significance. Okay, let's go through the answer choices. Okay, so let's go to the wrong answer choices because it's always nice to go through and figure out why they're wrong. Okay, so let's start with the bottom one. P is 0.417. Since P is greater than 0.05, we do not reject the null hypothesis. That part is true. And determine that the next part, and determine that we cannot be 95% confident that there is a significant difference in how long the tires last. That is throwing me off tremendously. Renai, do you understand what that means?
Well, I'm trying to understand it. Please, we do not reject determine we cannot be 95% confident that there's.
Here, let me see what the other one is. That okay, you know what? That's kind of okay. So we'll just keep it off to the side. We won't eliminate it yet. Okay, and then we'll look at the next one. Since P is greater than 0.05, we reject the null hypothesis. That automatically is incorrect because we know that the P value has to be less than 0.05 in order to reject the null hypothesis. Same deal over here. Since P is greater than 0.05, we have to accept and keep the null hypothesis, which is why this is incorrect as well. Up. See, you wouldn't have to really know why this, what this makes sense once you put the values in and solve for it. So let me walk through that first. Okay, so since this is a t-test, we're trying to see tread life of its new tires values. Okay, so since we're working with the same variable, we know, and we're comparing, are we comparing the means? Yeah, we're comparing the means. So great, okay. So since we're comparing the means and we know we're working with the same variable, we know that that's the automatic indicator of t-test. So with t-test, pretty simple. You would take the new tire values and put that, wait. Yeah, no, you could put the new tire values in column 1, 130, 135.
And we're comparing the new tire and seeing if that one's more than.
Yeah. So the greater sign has to be the new tire. 1 is greater than 2. I'm gonna do this as well because I don't know. I want to make sure. Okay, stat test. Number 4, 2-sample t-test. Data L1, L2, frequency 1, 1, frequency 2, 1. And then first mu is greater than the second mu. Pooled, yes. Wait, we're not. It's pooled, right? We have to click
Yeah,
yes for
pooled is
pooled.
yes. Pooled is
Okay,
yes.
cool,
It's
cool.
always yes.
Okay, great. And then yeah, okay, perfect. So and then the p-value I got was 0.2085. You would round that up to 0.209. So automatically with just that value, you could reject this one. You could reject the last two answer choices. So since we already said that this was an incorrect statement, eliminate that, and we are left with this. So yeah, that works. I was kind of choppy on that explanation, so I apologize. Again, if you ever need any clarification, you could always text me and I'd be happy to help. Okay. And plus, also, if you this far in the video, the last 2 videos I made were pretty, I think I went into much more depth into each of the tests, so hopefully that is also of help. Okay. Question 21. In 2019, approximately 97.4% of all the runners who started the Boston Marathon in Boston, Massachusetts, USA, were able to complete the race. Miles was analyzing the data with a Chi-Square test for independence to determine if the likelihood of a runner finishing the marathon is independent of the runner's age. Below is the contingency table of the data he collected. This is question 21. Okay. Find the Chi-Square statistic for the data. Round your answer to 3 significant figures. This one is actually pretty fun. I like matrices, so I like putting in values into the matrix. So since we are working with 2 different variables, we know that this is a Chi-Square, and it's asking for the Chi-Square statistic. We know we're working with Chi-Square test of independence because it also stays right there in the question. So when it mentions that, we know that we have to use matrix. So second, and then x to the power of -1, which is matrix. Go to edit. And then we have, make sure not to include the total because that's a common mistake that I always seem to make as well. So we have 3 rows with 2 columns. So it is a 3 by 2. And then put in all of the values. You would go row by row. So first 10,752, and then 320, and then so on and so forth.
Wait, isn't it 2 rows with 2 columns? Wait,
no,
no,
it's
columns?
3 rows. 3 rows.
3 rows. Wait.
Yeah. Rows are horizontal, columns are vertical.
Right.
3 age ranges. Yep.
Right. Yeah. Okay. No. Right. You're right. That's what I'm talking about.
All good. Okay, and then after you put in all of those values, always make sure to quit after you're done putting in values because it helps, like, I don't know, not stabilize your calculator, but like gives you a clean slate so like things don't get messed up in between processes. Okay, so second, quit, and then you want to go to stat, calc, go all the way down. Oh no, stat, test, my bad. Go all the way down, find chi-square test, and then you would get the, here, let me make sure I got it right. Yeah, you would get the chi-squared statistic of 43.4660. And then when you round it to 3 sig figs, you will get 43.5, which is also really simple. I really like statistical tests. I have no idea why. Okay. Yeah, so that was pretty simple. Matrix, plug in values. Yep, pretty straightforward. Okay. Next question. Number 22. Okay, you are carrying out a chi-square test for independence and have the following information. The significance level for the test is 10%, so 0.10 or 0.10. And then chi-squared. When it says calc, you know that that's chi-squared statistic, not the critical value. is 18.7, and the expected value for each cell is greater than 5. Okay. Which of the following would lead you to fail to reject the null hypothesis? That's sorry, I'm talking over myself. That's just a fancier way of saying what would have to make you, well, under what circumstances would you have to keep your null hypothesis so you can't reject it? Okay, so let's go through the answer choices. Calculated p-value is 0.099. So since that is less than the significance value, you could reject your null hypothesis, so that is wrong. Same deal over here. Since 0.011 is less than 0.10, you could reject your null hypothesis, so that is also wrong. And then we are given the critical value of 16.3 with the chi-square statistic of 18.7. And since the chi-squared statistic is greater than the critical value in the answer choice, you would also be able to reject the null hypothesis. That is also incorrect. And then finally, we come to our correct answer choice with the critical value of 21.2 and our chi-squared statistic of 18.7. And since that is less than the critical value, we cannot reject our null hypothesis. So we have to accept, and that is the correct answer choice. Okay. Yeah, next question. 23. I like the last half of this Kognity assignment better. I don't know, it came way easier. All right, question number 23. A student wants to test the hypothesis that gender affects the number of hours of sport watched on television. He selects 150 people equally divided between two genders, males and females, and categorizes them as watching sport almost, never, sometimes, regularly. Yeah, almost, sorry, I read that as there were 4 different things. Sorry, okay, let me start over. As watching sport almost never, sometimes, and regularly. Okay. He has 32 people in his sample who watch sport regularly. What is the expected frequency of females who watch sport regularly? Okay, so if all of this is very confusing, I will talk my way through a simpler thing to comprehend, simpler process to comprehend. Okay, so here's a question. Okay, so he selects 150 people. So that's the total value. So that's the first value you would put in your calculator, just off the bat. So 150, right? So it says, so then we're talking about, then we see he has 32 people in the sample who watch sport regularly, right? So the next value in your equation would be, I would put this in the parentheses, would be 32 divided by your total, which is 150. And then the next value you're going to multiply, I would put this also into parentheses, is the number of females. And since in the question it tells us that the sample is equally divided between the two genders, you could divide 150 by 2, which is 75. So then you would have 175, not 175. 75 divided by 150. And then once you multiply 150, and then open parentheses 32 over 150 close parentheses, multiplied by open parentheses 75 over 150 close parentheses, you will get your value of 16. So hopefully that makes it a little bit easier to understand. So yeah, this should be a super easy question. Just need to understand the process of doing it. Should be easy point if it's on the test. Okay, question number 24. Okay. Here we go. This one's also a really simple question. A student wants to test the hypothesis that age affects reaction time. So we see right here there are 2 variables in question, age and reaction time. So because of this, we know that we're working with chi-square test of independence. Keep in mind that for chi-square test of independence, there's a different formula for when it asks degrees of freedom. For degrees of freedom, then there is with the goodness of fit test. So I would remember that. I will go over those two formulas in a bit. He selects people in 3 different age ranges and determines a reaction time to be fast, medium, or slow. How many degrees of freedom will there be in his chi-square test? So the formula for the chi-square, for the degrees of freedom for a chi-square test of independence will be rows minus 1 and the number of columns minus 1. So since we have 3 different age ranges, which is 3, and then fast, medium, slow, which is 3, minus subtract 1 from each of the 2 values, which then you would get 2, and then 2 times 2, you would get 4. And then I don't want to confuse you, but let's say if this was a goodness of fit test and they were asking us for the degrees of freedom, we would just take, oh no, I'm confusing myself. Since there would only be one variable in, since there would only be one variable in question, you would take the amount of that variable. So let's say we were looking at like colors of marbles. So let's say there were 6 different colors. You would take the total number of, different like colors and then subtract that by 1 and you'd get 5, which would be your degrees of freedom. I hope that wasn't confusing because I switched between the two.
It helped, don't worry.
Okay, cool. Sorry, I'm just overthinking this. So yeah, the formula is right here too if you need it. Yep. Okay. 25. This 25 is an expected frequency question, which is also another one of my favorite type of questions. Okay. Number 25. Susanna wants to test the hypothesis that the choice of desert depends on age. Again, 2 different variables, chi-square test of independence. Even though I don't think that's really relevant to the question, but I just want to put that out there. Okay, she surveys 174 guests at a wedding reception, and the results are shown in the following table. Calculate the expected number of 11 to 20-year-olds who chose fruit salad or dessert. Give your answer to 3 significant figures. Okay, so firstly, what is the total number of whatever is in the question? It is 174 guests. So I would put that value in your calculator. 174, right? And then we are looking at 11 to 20-year-olds first. So I would follow that all the way to its total. And then you see that we have 31. So I would then multiply 174 by 31 over 174, which is a total. And then the next number you're going to multiply all of that by is the individuals who chose fruit salad for dessert. Very weird, very odd. Not shaming, but couldn't be me. Wouldn't be me. Okay, so fruit salad, and we have a total of 33. So then after we have 174 multiplied by 31 over 74, we're multiplying that by 33 over 174. So I'm going to read out the equation one more time. 174 multiplied by 31 over 174 multiplied by 33 over 174. Parentheses will be very useful for these type of questions. Okay, so once you multiply all of that together, you should get a final value of 5.879. And then since you got around to 3 significant figures, yep, you will get 5.88, which is shown here. Oh, yeah. Because see, if I were to go through this, like just go through this after this, I don't think I'd understand what's going on. So I really do hope that me talking through this helps some of you. Okay, next question. 26, okay. Luke wants to test the hypothesis that the average number of hours a student sleeps per night influences their average grade. 2 elements, hours of sleep per night and average grade, chi-square test of independence. He surveys 200 students and the results are shown in the following table. Calculate the chi-square test statistic, giving your answer correct to 3 significant figures. Okay, so pretty simple. Also, one of my favorite questions. You would go to matrix, And then we have three rows with 3 columns. Okay. And they made it easier to differentiate total between the actual variables in question, but they won't always do that. So you always have to be observant. But no, here it's pretty straightforward. That would be a 3 by 3. And then plug in the values going from rows. So the first row would be 13, 15, 8, and so on, so forth. So I'm going to do that real quick. Okay. So and then I would quit because I like having those different processes without going straight to it because I don't want to risk messing anything up in between. So then I would go to stat, test, go all the way down to chi-square test, not goodness of fit, just straightforward chi-square test. And then click calculate, and then your chi-square statistic should be 1.409. But when you're on the 3 significant figures, you should get 1.41, which is the answer as shown below. Okay. Question number 27. Okay, this one was a bit confusing at first, but after working with it in groups and with Ms. Sinha, it made a little bit more sense. Okay, so question number 27. The quality control manager at a concrete company knows that the ideal ratio of dry ingredients to make concrete with is 1 part cement to 2 parts sand to 3 parts gravel. The manager decides to test the quality of their manufacturing process by randomly selecting one batch that is being mixed and measuring how much of each ingredient is added to make the new batch. He finds that the batch contains 5 meters cubed. Okay, I don't know. 5 meters cubed of cement, 9 meters cubed of sand, and 10 meters cubed of gravel. I'm sorry if I completely butchered that. Determine whether the manager's sample is consistent with the ideal ratio using the chi-squared value and a 0.05 level or 5% level of significance. Okay. Let's see the answer choices. Okay, you know what? Let's solve first. Let's see what we have to do. Sorry, I'm a mess. Okay. So in this case, I would have the Kognity with the answer explanation pulled up, so it would be a little bit easier to follow along. But first, we want to look at the observed values, which will be given to us in the problem. So we have the observed values of 5 cement, 9 sand, and 10 gravel. So when we looked at this little section right here, that's going to help us figure out the expected values for each of the observed values. So we want to add all of these parts together. So pretty simple, 1 plus 2 plus 3, which is 6. So we're going to take, with cement, we're going to multiply 5 by 1/6. Oh my God, am I doing this right? 5 times 1/6. Oh, nope, scratch that. Scratch that. Okay. Okay, not 5 times 1/6. Okay, so observed values, starting over, 5 cement, 9 sand, 10 gravel. So then you want to focus on these parts, and then you want to write the fractions in regards to the total. So for cement, it would be 1/6. For sand, it would be 2/6. And then for gravel, it would be 3/6. And I know you'd be tempted to like simplify it like 2/6 to 1/3 and 3/6 to 1/2. But that might make it a bit confusing. So if I were you, I would just keep everything with the same denominator. I would think it would be simple. So then you want to add all the observed values, which is 5, 9, and 10 together to get the total of those, which is 24. So then you want to take the fractions that we just came up with and then multiply each of those with the total of the observed values, which is 24. So going down, it will be 1 over 6 times 24, 2 over 6 times 24, and 3 over 6 times 24. So I'm going to pull it back down. You would get 4 for cement, 8 for sand, and then 12 for gravel. Those would be your expected values. So then, since it's goodness of fit, you want to go to stat, edit, plug those values in the calculator, just 6 values.
Also, by the way, for the 2 out of 6 and things like that, you can simplify it. It says it right there, like 1 out of 3 and 1 out of 2. So you can simplify it.
No. I mentioned that you could simplify it, but if it gets a bit confusing and like personally, I would keep it with the same denominator, so it makes it just easy to keep track of.
Okay, get it. All right, yeah.
Yeah. Okay. So 5, 9, and 10 into your first column, and then 5, 9, and 10 into your first column, and then 4, 8, and 12 into your second column. Then stat, tests, go all the way down and find chi-square goodness of fit. And then for this, since, let me just change my L3, L4, okay. Degrees of freedom, since we have cement, sand, and gravel, that's 3 minus 1, that would be 2. Calculate, I forgot to quit in between. Let me do that again. Okay, got it. So I got chi-squared value of 0.708. So looking at the answer choices, you could automatically eliminate 0.711 and 0.711. You can eliminate these two. Okay, so now looking at this incorrect choice. So since p-value is greater than 0.05, we have to accept null hypothesis. We cannot reject null hypothesis. When we say we reject null hypothesis, we're saying that the relationship is significant, but it is not because the value is a lot bigger than 5%. So we want to go back to our correct choice, which is our chi-squared value is 0.708, which we got. And then since p is greater than 0.05, we do not reject h sub 0. We have to accept it. And at the 0.0 level of significance, the ratio in the sample is consistent with the ideal ratio. So yeah. And then, I don't know, I think I mentioned this in the last video too for the other statistical exam review, but for the null hypothesis, you wouldn't be changing anything. So it'd be that the workers are making the concrete according to the ideal ratio. That means everything's okay. That means nothing has to change, which is how I kind of try and remember it. And then the alternative hypothesis would mean that the workers are not making the concrete according to the ideal ratio. That means something is not going the way it's supposed to be. There needs to be a change. So yeah, that is question number 27. I kind of screwed up here and there, but hopefully not too bad. Okay, question number 28. For any hypothesis test, which of the following conditions would lead you to reject the null hypothesis and accept the alternative? Okay, before we even look at the choices, would lead you to reject the null hypothesis and accept the alternative. Okay, so we have stated before that if the p-value is less than the significance value, the relationship is significant, meaning that we would reject the null hypothesis. And if the chi-squared statistic from our calculator is greater than the critical value, then that also means that the relationship is significant, which means we also reject the null hypothesis. Now we will go look at the answer choices. Let's look at the incorrect ones first. The calculated test statistic is less than the critical value. So if that is so if that happens, that the value from my calculator is less than the critical value, that means that we cannot reject the null hypothesis. The calculated test statistic needs to be greater than the critical value, so that is incorrect. Okay, the calculated test statistic is less than the significance level of the test. But wait, why are we comparing the test statistic to the significance level? That's right, we don't. So that's obviously there to throw you off and mess you up. So we cannot compare those two together. P-value with significance level and test statistic with critical value. Remember that.
That's, I guess, the same thing with the p-value less than the critical value.
Yeah, same thing right there. So you can't compare the p-value with the critical value. So remember that. That's also there to throw you off. So ultimately, the calculated p-value has to be less than the significance value. Oh, sorry. The calculated p-value has to be less than the significance level of the test, or the calculated test statistic. Oh my God. The calculated test statistic has to be greater than the critical value. Jeez, it's so hard to talk through this unit. Okay. Yeah. We've gone through so much practice. This needs to be ingrained into your minds by now. But again, honestly, I can't blame you if it's not. It's been rough. Also, writing it over and over again helped me remember. That's what I did when we were going over this in biology, because I didn't understand it all. I just memorized it blindly, and that did not help me. So try to understand why the null hypothesis and null hypothesis, and why the p-value has to be less than the significance level.
You mean math AI? Sorry, you took the biology test and you said that, but it's fine.
No, we learned this in biology too, actually.
Oh, really? Oh, well, I'm stupid. Never mind.
No, no, that's fine. I would have probably said the same thing as you. Yeah, no, we learned this earlier in quarter 3, I think. So yeah, it was like a little introduction before math. And we actually learned about null hypothesis and alternate hypothesis in psychology as well. So all of that kind of helped me with math as well. So that's kind of an advantage. All right, question number. I'm kind of surprised that the meeting is still going. I think it's because only one person joined, so there's no limit. I don't know if you noticed that or not.
Really? I don't know. I don't know if it's like
No, it's been more than an hour.
Oh wow. All right.
Yep.
Well.
All right. Question 28. We just finished that. Question 29. Okay. Petra wants to test the hypothesis that the amount of money spent on clothes is independent of gender. She carries out the Chi-Square test of independence at 1% significance level, which is 0.01, and determines that the Chi-Square test statistic, so this is what you get from your calculator, is 15.7, and that the p-value is 0.0034. The critical value is found 13.3. What conclusion should she draw and why? Okay. Here, let me just process this real quick. Okay, so okay, I'm sorry, I don't know why. Okay, so 1% significance level, which is 0.01. I would always convert the percentages to decimals, because sometimes, like with 5%, you could think you're working with the number 5, which is incorrect. So I would always convert it to a decimal. Okay, and the p-value is 0.0034. I would also write that down on like scratch paper during a test. So we have the p-value 0.034, which is less than 0.001. I mean 0.01, sorry. Right, so based on solely just that, we can reject the null hypothesis. Reject no. Okay, next thing we have Chi-Square test statistic is 15.7, and the critical value is 13.3. So I would also write that down. Chi-Square test statistic is 15.7, which is greater than the critical value of 13.3. And also based on that, we can reject the null hypothesis. So when we go down to the incorrect answer choices, money spent on clothes is not independent of gender because the Chi-Square test statistic is greater than the p-value. Same thing as last time, you cannot compare those two together. So that should be super easy to eliminate right off the bat. Cannot compare chi-square statistic with p-value. Cannot do that. So eliminated. Money spent on clothes is independent of gender because the p-value is less than the significance level. Well, those are two contradicting things, because if the p-value is less than the significance level, which it is, that means that they are not independent of each other and that they do have a relationship. So that is also incorrect. Money spent on clothes is independent of gender because the chi-square test statistic is greater than the critical value. Same concept as the last one. That's two contradicting things, because if the chi-square test statistic is greater than the critical value, that means there is a relationship, meaning that they are not independent of each other. So that is also wrong. So the answer is money spent on clothes is not independent of gender because the p-value is less than the significance value. These are not contradicting statements and they fall under the same thing, meaning that since the p-value is less than the significance level, that means the relationship there is a relationship present. So they are not independent. They correlate with each other. They have a relationship. Okay. Next question. Ruth wants to test the hypothesis that that favorite car color is independent of gender. She carries out the chi-square test at 5% significance level and determines that the chi-square test statistic is 4.31 and that the p-value is 0.0730. The critical value is found 7.82. Okay, so let's do the same thing as we did last time. Let's write down that the p-value is 0.0730, right? And then what? The significance level is 5%. So the p-value is actually greater than the significance level because 0.07 is greater than 0.05. So based off that alone, we know that we have to accept null for what it is, and we cannot reject. Okay, and then let's go to the critical and chi-square statistic. So let's write that. So we usually solve for the chi-square statistic, but they gave it to us, so that was the first value I would write. So that is 4.31, and the critical value is 7.82. So also based on this, we cannot accept the null hypothesis because the chi-square test statistic has to be greater than the critical value. So with that in mind, let's go through the answer choices. Favorite car color is not independent of gender because the p-value is less than the significance level. So since we have come to the conclusion that they are independent because they do not have a significant, because there is no relationship. So they are independent, so they're not independent. Sorry, that doesn't make sense. But these are two contradicting statements. Well, no, let me recoup. These are not contradicting statements, but it doesn't apply to our situation. The p-value was greater than the significance level, so that means that the favorite car color is independent of gender, so that is wrong. Favorite car color is not independent of gender because the chi-square test statistic is less than the critical value. Okay, so that's a contradicting statement. If the favorite car color was not independent of the gender, that means the chi-square test statistic has to be greater than the critical value, which isn't our case, because for us the chi-square test statistic is oh my god, I lost it again. The chi-square test statistic is less than the critical value, which means that they are independent of each other. So those are contradicting as well. Okay, favorite car color is independent of gender because the chi-square test statistic is greater than the significance level. So if the chi-square test statistic is greater than the significance level, that means that they are not independent of each other. That means they do have a connection. They do correlate with each other in some sort of way. They have a relationship. So that is also incorrect. So looking at our answer choice, our correct answer choice, favorite car color is independent of gender because chi-square test statistic is less than the critical value, which is correct. They are independent of each other because two reasons. P-value is greater than significance level, which it's not supposed to be, and our chi-square test statistic is less than the critical value, which it is also not supposed to be. And with that, I have finished all the questions other than 5 through 11. Yeah. Okay. I think Alan, I'm not sure, but I think if you go back to the other reviews, I think Alan went over binomial distribution, the RevisNow that he led. So I would go through the other videos and try to find that. But hopefully I will be able to make the next video, but honestly, the chances are slim because I have a French project due in the morning, which I have not started on, which is my mistake, and I wasn't prepared for this, which is on me. But I know that Miss Sinha has a bunch of notes posted from our previous units too, so hopefully that should help as well. And I don't know if you've made it this far. Thank you for watching. Thank you for viewing, being subscribed, whatnot, etc. And well, oh my God, this is the last review for our school year, for our junior year. So I will.
That's heavy. That's very.
Oh yeah, that's heavy. Oh yeah, so yeah, I will see you guys next year. I mean, you know what I mean. But yeah, good luck on your finals. Yeah, I hope all goes well. And yeah, I think I will sign off. Thank you again.